Hello, welcome to another practice session for numerical questions. So in this NAT type question session, we're going to practice some questions from pH and pKa. So in the last moment, the NAT section can change your game. So obviously practicing NAT question is really important. All of these NAT questions that you would be seeing today is based on previous year analytics, previous year question types. So you can count on these questions. So what are the topics from which the NAT questions are asked from? So we need to look at the analytics to answer that. Generally, a lot of questions are asked from NMR spectroscopy, then genetics, enzyme kinetics, microbial growth, biomolecules, probability, and also from molecular biology. So today what we are going to do is basically look at some questions from biomolecules, and among that we are going to look at some pH and pKa related problems. Sometimes this could be confusing to many people. It was also confusing to me when I was giving this exam, so that's why this video is dedicated for that. But before that, let me tell you, tomorrow there is a all India mock test happening in Unacademy. If you haven't enrolled yet, click on the link which is in the description box. Now go and enroll yourself, because this test would be a all India one, and it's your chance to understand where do you stand in a all India crowd. If you do substantially well, you would get a Amazon voucher which is 65k, and you can get whatever you want from Amazon. That's a lot. Now this test is starting from 11 a.m. and it's going to be 180 minutes. It's a full scape mock test for IIT JAM. You just need to use my code AP10 to register for free. You don't need to be a plus subscriber in order to take this test. By the way, I have a bunch of lectures which are really helpful for an IIT JAM, and all of them are for free. Link is in the description. Question number 1. The net charge on the following peptide at pH 7 is dash. So you have a peptide given here, and whatever is asked is the overall charge on this peptide at a pH level 7. So the particular charge on the peptide is depending upon what type of side chain does it has. Look at here. Here they have obviously the N-terminal NH2 group. Then also there is a side chain amine group from the lysine. There is a carboxy group from the C terminal and the carboxy group from the glutamate side chain. Now we have to understand at particular pH whether it is protonated or deprotonated. So look, the simple formula is if pH is greater than the pKa, then deprotonation would happen. Then what happens is the protons are abstracted from this particular amino acid and taken in the environment. So it loses proton and it remains in a deprotonated state. So -1 is the charge. So here what we can see, there are two protonation, two deprotonation. So +2 positive charge and -2 negative charge. So obviously the overall charge would be 0. So how do you know what is the pKa for these C-terminal CO minus or N-terminal amino group? So this is the list that is provided. Now this list is important. You don't need to remember this list. So overall the way you remember is basically for all the CWH group at the C-terminal, the overall pKa range is like in between 2 to 2.5, and for all the amine terminal ones, the overall the pKa range is from 8.5 to like 9.5 range generally. So obviously you can get a rough estimate about it, but these informations are generally provided in the question. Anyway, this kind of question was asked in IIT JAM 2016, so you can understand this is a really important question. So what is the take home message? Take home message is we just need to look at what is the pH. What is the pH which is stated in the question? Is it greater than the PA or lesser than the PA? If it is lesser than the pKa, sorry, I said PA maybe. So if it is lesser than pKa, then the group would remain protonated. If the pH of the current solution is greater than pKa, then it would lose proton and it would be deprotonated. By the way, you don't need to remember every single details, but the pKa for the side chains for these 4 amino acids, you should keep it in your head. such as lysine, arginine, aspartic acid, and glutamic acid. These are the acidic side chains that determines the overall charge. So obviously you should remember the side chain pKa's. Okay, now question number 2. Net charge of this amino acid at pH 3 will be. So the proforma is same. This is a question type that you need to solve. At every particular region you have to see that whether it is greater than pKa or lesser than pKa. For example, you can understand here the overall charge would be +1. Why is so? Because let me show you. So here what you can see that at this particular group, you can see the pH is 3, which is greater than pKa, so it would be deprotonated and there would be a negative charge. Here the pH is lesser than 6, so it would remain protonated, right? So here the charge is +1, and also pH is 3, which is lesser than pKa, so it would be remaining in a protonated state. So overall we see 2 positive charges and 1 negative charges, so overall there would be 1 positive charge. Now you can try this one. Net charge of the amino acid at pH 7 will be. So again the same formula, you have to see whether 7 is greater or lesser than the particular pKa value. So for this particular region you can see 7 is greater than pKa, so obviously it would be deprotonated. And also here it is basically 7 is greater than 6, so overall it would be deprotonated, so proton would go out but there would be no negative charge, it would be in a neutral state. So here what you can see that in this particular group you can see the pH is 7, the pKa is 9.6, so it would stay in a protonated state. So obviously you can see there is a plus charge and there is a minus charge, so overall it would neutralize each other and the overall charge would be 0. Okay, great. Now you try it yourself and let me know in the comment. The net charge of the amino acid at pH 12 would be dash. Write it in the comment section. Then there are proforma of question which can say which one of the following form of lysine will predominate at pH 9.5, and all the pKa values for all these groups are provided. You need to find this. So this question is again based on the previous question. So here what you have to do is basically look at each of these chains. So look at side chain. So in the side chain what happens, the pH is basically 9.5, right, and the side chain has a pH of 10.53. So obviously pH is not greater than pKa. In that situation the protonation state would remain, so you can at least understand protonation, this particular group would be protonated. So at least the examples where side chain is protonated you have to choose that. Then we come to a particular let's say the carboxy terminal. In this carboxy terminal we can see that the pH is 9.5 and it is greater than 2.18. So obviously proton would be lost for this particular group, right, and it would have a negative charge. That's great. And let's look at the pKa value for the alpha NH2 group. So here what happens is like pH is 9.5, which is greater than uh, the NH3 group. So obviously what would happen, there would be a deprotonation reaction, so one hydrogen would go out and the NH3 would become NH2. So right now option A is the correct one. Now question number 4 says net charge on arginine at pH 10 will be. So you have to solve that. Try it yourself. But anyway, for solving this question you need these information. Using this information try to solve that. You have the pKa for the amine group, the main chain COH group, and also the side chain amine group is provided, so you can use that information to solve this question. By the way, the amino acid alanine has two pKa values, 2.3 for the COH group and 9.7 for the NH3 plus group. The pi of or isoelectric pH for the isoelectric point for this particular compound is what? So in order to solve this question, what you really need to do is basically use that formula where pi equal to half of the two pKa values. Here you have to add these two pKa values 2.3 and 9.7, and then the half would be your answer. So 6 is the correct answer. Anyway, these are the simple thing that you need to understand. So for a simple amino acid, the half of the sum of these two pKa values would be the pi, but things are different when it's a basic or an acidic amino acid. For an acidic amino acid, you have to take pKa1 and pKa3, whereas for a basic amino acid you have to take pKa2 and pKa3 into consideration. So pi would be half of pKa2 and pKa3, and the reasons are provided briefly in this particular content. So all these contents are available in my Facebook page. Don't forget to go there and check it out. You can download that, keep it with you, it's really handy. So moral of the story that you need to take home, like this is the take home message: what is the pi for normal amino acids? That is pKa1, pKa2. But if it is basically acidic amino acids, it's going to be the pKa for all the COH groups, and if it's a basic amino acids, it's the pKa for all the side chain and the main chain NH3 group. So this is the moral of the story. Anyway, all of these notes and all these important tricks are provided in the Facebook page. You can check it out, and if you like this video, give it a big thumbs up. Don't forget to like, share and subscribe, and you can support my channel on Patreon. My courses are on Unacademy. You can take a subscription using my code AP10. It would give you a 10% discount. Thank you. See you in the next video.